I welcome you all for this lecture series on 4G and 5G communication networks. In this lecture number 14, we will briefly discuss about evolved packet core, that is EPC for 5G. So first, we'll see the overview of evolved packet core and how it is used in the 5G. The evolved packet core EPC is the central architecture originally developed for 4G LTE networks, designed to manage data transmission, signaling, and connectivity between mobile devices and the network. In the context of 5G, the EPC has evolved to support the new requirements and capabilities of 5G networks, especially in non standalone NSA deployments where it works alongside 5G new radio, that is NR. It acts as a backbone by efficiently managing user data, controlling network connections, ensuring mobility management, and maintaining the quality of service QoS. This makes EPC a critical component in bridging the gap between 4G and 5G technologies, enabling seamless communication and connectivity for mobile users during the transition to full 5G deployment. And coming into the architecture and components, and the first one is the MME, Mobility Management Entity. The Mobility Management Entity MME is a critical component of EPC, that is Evolved Packet Core, and it is responsible for handling the control plane functions related to signaling and mobility management. It manages tasks such as user authentication, session control, handovers between different base stations, and tracking of user devices they move across the network. The MME ensures that device remain connected and can seamlessly transition between different network towers or cells without losing connectivity. This is the function of mobile, that is mobility management entity. Next one is SGW, that is serving gateway. The serving gateway SGW plays a key role in managing user data and forwarding data packets between the E node B base station and the packet data network gateway. This PGW represents what? Packet Data Network Gateway. It is responsible for routing and transferring data packets while the user is connected to the network. Additionally, the SGW, that is Serving Gateway, acts as a mobility anchor when a device moves between different e-node Bs and ensuring uninterrupted data transmission during handovers. The next key component is the PGW, Packet Data Network Gateway. The Packet Data Network Gateway PGW is responsible for providing IP address allocation, managing packet routing, and connecting the mobile users to external networks such as internet. It handles the user's data sessions and ensures that traffic is routed correctly between the mobile network and external data networks. The PGW Packet Data Network Gateway also supports functions such as traffic filtering, charging, and enforcing data usage policies. The next key component is the PC or policy and charging rules functions. And the policy and charging rule functions, PCRF, oversees QoS, that is quality of service, and charging policies within the networks. It enforces rules related to data prioritization, bandwidth allocation, and usage limits for different services. By managing three policies, the PCRF ensures that network resources are distributed efficiently, providing an optimal experience for users while also enabling operators to charge for specific data services or enforce usage restrictions. That's all about the architecture and the components of EPC. Next, we'll move on to the EPC's role in 5G and as a non-standalone architecture. The 5G NSA uses EPC to leveraging existing 4G LTE systems while adding 5G NR for faster data speeds. In 5G non-standalone 5G NSA architecture, the evolved packet core is used to integrate the existing 4G LTE infrastructure with 5G new radio technology. This allows mobile operators to offer enhanced data speeds and reduced latency without completely overhauling their network infrastructure. The EPC continues to handle key functions such as mobility management and data routing, while the 5G NR provides the faster data transmission rates associated with 5G. This hybrid approach allows for a smoother and faster implementation of 5G services while still relying on 4G components. Next, we'll see the benefits of N as a non-standalone architecture. Gradual evaluation to 5G with minimal charging to existing network infrastructure. What it means, the main advantages of 5G NSA architecture is that it allows for a gradual transition to 5G minimal modifications to existing network infrastructure. Instead of replacing all 4G elements, what it will do is operators can build upon the EPC and LTE networks, thereby reducing the cost and complexity of the upgrade. This evolutionary approach offers a faster rollout of 5G services and allows network providers to extend coverage while continuing to rely on 4G technology for core network function. As a result, what will happen? Users benefit from faster speeds and improved connectivity without the need for an immediate full scale transition to a standalone 5G network. That means with the available 4G resources, we can able to adopt the 5G. And next one is the EPC and 5G standalone core. This is the entirely different thing what I discussed in the previous slide. The 5G in 5G, the standalone SA architecture, 5G core 5G core that we can call it as 5GC is introduced. This 5GC represents 5G core, introduced as a completely new network architecture that does not depend on the EPC, that is evolved packet core. Unlike the non-standalone NSA architecture, where EPC remains essential, the 5G core is specifically designed to support 5G functionalities from the ground up. It handles both the user and control planes for 5G networks, offering a more flexible and future-proof solution compared to the legacy of 4G based evolved packet core. And the 5G core offers, no, see here, this we have discussed many times. The 5G core offers better network slicing, lower latency, and improved performances. No? It allows operators to create multiple virtual networks tailored to different services and applications. The future enables more efficient use of network resources for diverse use cases like autonomous vehicle, IoT, and enhanced mobile broadband. Additionally, 5G core reduces latency. This we have seen already, providing real-time responsiveness needed for critical applications like industrial automation and telemedicine. Its overall performance improvements ensure higher data throughput, greater scalability, and enhanced user experiences. Next one is the EPC. EPC is still relevant during the transition period as operator upgrade to 5G. How it means? Despite the advancement of 5G core, the EPC remains relevant during the ongoing transition from 4G LTE to 5G. Uh, Many operators will continue to rely on EPC in 5G NSA deployments as they gradually upgrade their networks a full 5G standalone architecture. That is the main aim of the new research. During this period, EPC supports 5G services in conjunction with 4G infrastructure, ensuring a smooth and cost effective evaluation toward fully integrated 5G core networks. As operator shifts to 5G core, EPC will eventually be phased out, but it plays a key role in the interim. Next, the key features of EPC for 5G. The evolved packet core has been enhanced to support the increased data demands of 5G networks. With the integration of 5G, new radio, EPC enables higher data rates, allowing users to experience faster download and upload speeds. Additionally, EPC improves mobility management, ensuring that users can seamlessly transition between different network areas even when moving at high speeds. This is essential for applications like video streaming, online gaming, and other data intensive services while require both high speed data transfer and stable connectivity. Next one is the low latency for applications like autonomous driving and industrial automation. How it means? One of the most significant enhancement of EPC for 5G is its ability to support low latency communication. Latency refers what? Refers to the time it takes for data to travel between 2 points in a network. And EPC's low latency capabilities are crucial for real time applications like autonomous vehicles, which require instant data transmission to ensure safety and reliability. This is very, very important property. Similarly, industrial automation, including robotics and smart factories, benefits from near instantaneous communication between devices, which is essential for efficient and precious operations in critical environments. And the next enhancement is the EPC no integrates IoT devices, improving connectivity and scalability. How it has been done? The EPC has also been upgraded to support the vast number of IoT, Internet of Things devices that 5G networks are expected to connect. By allowing more efficient device management and resource allocation, EPC improves the scalability of the network, enabling the seamless integration of billions of IoT devices. This enhanced connectivity is crucial for the deployment of smart cities, connected homes, and industrial IoT solutions where devices need to communicate and exchange data reliably across large scale networks. Next purpose is the security. To address the increasing security demand for 5G, the EPC incorporates advanced security features including data encryption and enhanced network access control mechanism. These improvements ensures that data transmitted across the network is protected from potential threats, safeguarding sensitive information. Additionally, the enhanced authentication and authorization procedures help secure user access to the network, preventing unauthorized devices from compromising the integrity of systems. This focus on what? Security is particularly important in the 5G era, where more critical services and personal data are transmitted over mobile networks. Next, EPC evolution and 5G core integration. As network continue to migrate to 5G core, that is 5GC architecture, the evolved packet core, this 5G core, okay, evolved packet core will gradually be phased out. While EPC has been instrumental in supporting the transition to 5G in non standalone deployment, the introduction of 5G core designed specifically for 5G's unique capabilities will eventually render EPC absolute. The 5G offers advanced features such as what are all the advanced features? Slicing, ultra low latency, better scalability, which are essential for fully realizing the potential of 5G. As operators embrace more cloud native solutions and virtualized network functions, EPC's role in handling user data and network control will diminish, giving way to more flexible and dynamic systems that better meet the demands of next generation applications and services. This shift makes the next step in the evolution of mobile network infrastructure, prioritizing speed, efficiency, and adaptability. And coming to the conclusion, the evolved packet core has been instrumental in facilitating the transition from 4G to 5G. As operators look to upgrade their infrastructure, EPC, this evolved packet core, serves as a vital bridge enabling the integration of 5G new radio technology with existing LTE system. By leveraging the capabilities of EPG, mobile operators can gradually enhance their services without completely overhauling their network architecture, thus ensuring a smoother and a more efficient transition to 5G. And it supports faster data rates, low latency, and IoT connectivity. How it is happening? One of the key advantages of EPC is its ability to support increased data rates and lower latency, both of which are critical for 5G applications. With the integration of 5G NR, EPC enables faster download and upload speeds, significantly enhancing the user experience for data intensive applications. Additionally, the low latency capabilities of EPC are essential for real time applications such as autonomous driving and industrial automation. Furthermore, EPC's enhancement facilitate the connectivity of vast number of Internet of Things devices, enabling seamless communication across a diverse range of smart technologies. And next, as network adopts 5G standalone, this SA EPC will phase out, and as mobile networks move towards 5G standalone, that is without depending on the EPC, that is LTE standalone architecture, the role of EPC will gradually diminish. While EPC has been vital in the initial phases of 5G deployment, the new 5G core 5GC architecture is designed specifically to meet the requirements of 5G, offering advanced functionalities that EPC cannot provide. Consequently, as operator fully transition to 5G core, EPC will be phased out, making a way for a more efficient and agile network infrastructure that can better support the evolving demands of users and applications. The next one is the cloud native solutions will enhance performances and scalability. How it has been done? The transition from EPC to 5G core will pave the way for cloud native solutions. This is the very important property that offers significant improvements in performance and scalability. These modern architectures leverage virtualization and microservices, enabling more efficient resource management and dynamic scaling to meet fluctuating demand. This shift allows network operators to deploy new services more rapidly, adapt to changing market conditions, and enhance overall network resilience. The cloud native approach also fosters innovation, enabling the development of advanced applications and services that were not feasible with the traditional EPC architecture. Further, how this mobile communication will focus on innovative architectures? Looking ahead, the future of mobile communication will increasingly prioritize innovative architectures that fully harness the capabilities of 5G and beyond. This include the adaptation of flexible software-defined networks that can efficiently handle the diverse range of applications and the services emerging in today's digital landscape. By focusing on innovation, operators can better meet the needs of consumers and businesses alike, driving advancement in areas such as augmented reality, smart cities, and enhanced connectivity. As mobile communication evolves, the emphasis on agility, the performances, and user experience will be paramount. Next, and finally, in summary, the evolved packet core has been crucial in facilitating the transition to 5G, enabling faster speeds and enhanced connectivity. As we move towards cloud native architectures, the future of mobile communication will focus on innovation and meeting the evolving demands of users and applications. So that's all about the EPC for 5G. Hope everyone understood this topic. The remaining things we'll discuss in the next lecture.